In this video for day 8.2, we're going to be talking about quadrilateral characteristics, and you'll see this word that might intimidate you a little bit. We're going to prove quadrilateral characteristics, but we are not writing proofs. Again, listen to me when I say that. We are not actually writing a proof. So this is not like we did first semester. We are just using the characteristics of known quadrilaterals like parallelograms, a rhombus, rectangle, and square. We're going to use those characteristics and the relationships that we talked about in 8.1 of lines, whether they are the same distance or same slope or have the same midpoint, those kind of things, to take a look at these different characteristics. So it would be a good idea to start off our video with a reminder of the characteristics of parallelograms, rhombi, rectangles, and squares. Okay, we're going to really just focus on these ones I've highlighted, and I'll explain that to you more in just a minute. This is not your note packet. You don't have to write anything down. I just want you to listen and observe. Listen. Okay, so make sure that volume is turned on. All right, so in parallelograms, there's all these different characteristics. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and then the diagonals bisect each other. This is the most important one. We are actually just focusing on these three, okay? Because in the coordinate plane, it's very difficult for us to talk about angle measures. We really can't do that unless we're talking about right angles, like perpendicular segments. So we'll talk about that in a little bit. But we're going to focus on these three. So the first thing I want you to write down in your notes under parallelogram are those three bullet points. Number one, opposite sides are parallel, which means, like we learned from lesson 8.1, they would have the same slopes or equal slopes. Number two, opposite sides are congruent. Which means they have the same length. This is LE, length, as in our distance formula, all right? And then the other characteristic we're really going to focus on, the main one we're going to focus on, is that the diagonals bisect each other. Well, if two segments bisect each other, that means they have the same midpoint. So if I give you the ordered pairs for the four corners of a quadrilateral, we could use slope formula, distance formula, and midpoint formula to figure out that it was in fact a parallelogram. All right, so now we're going to take a look at rhombus and rectangle. In a rhombus, or the plural of that being rhombi, we have these characteristics. There are four congruent sides. The diagonals are perpendicular. And then diagonals bisect opposite angles. We're really not focusing on that one, just these two. So we're going to write those down. With a rhombus, we have four congruent sides. That means all four sides would have the same length. We would use our distance formula here. We also know the diagonals are perpendicular, which means they have opposite reciprocal slopes, like we talked about in lesson 8.1. And now we want to talk about rectangles also. In a rectangle, we have four right angles. Now, I said we can't tell a whole lot about angles, but that also means, if these are all right angles, that consecutive sides, meaning right next to each other, are perpendicular. All right, and so I could use the slopes of the consecutive sides to show that those are right angles. And then diagonals are also congruent, so we can use the distance formula there. So these are the two we want to use for rectangles. Okay, if there are four right angles, that means consecutive sides have opposite reciprocal slopes. And the other characteristic of rectangles is that diagonals are congruent, which means they have the same length. So we're really just using three formulas. Using slope formula, using distance formula for length, And then all the way up here, we will use midpoint formula sum. All right? And that leads us to squares. Now, if you'll remember, a square is any quadrilateral that has a characteristic of a rectangle and a characteristic of a rhombus. So anything that could be called a rhombus and a rectangle makes it a square. So squares have the properties of all three. Okay, so we don't have to do a lot of extra work to call it a square. If something is a parallelogram, a rhombus, and a rectangle, we make it a square. So to continue with our notes, what we're going to be doing in this lesson then is we are going to be using these characteristics to answer questions about parallelograms. So as we go to our next section of the notes, next page, I want you in this top right corner of this page, I want you to draw what appears to be a parallelogram. All right. Just draw that to the best of your ability. It is called parallelogram ABCD or quadrilateral ABCD that is a parallelogram. So I'm going to pick one corner and start with letter A and then just go around the parallelogram, B, C, D. Okay, I'm not going to try and trick you in this lesson. For just about every one of these, that order will be this order of points, whether it's a parallelogram, rectangle, square, rhombus. We're going to go in order. The order of these letters tells you to go around because that's going to tell you which sides are opposite sides, like AB is opposite CD. Okay, that makes AC a diagonal. So A and C form a diagonal. The other one is BD. That's the other diagonal. So when we talk about these figures, the order of those letters is very, very important. So in question one, or sorry, first example, question A. What is the slope of CD? Well, they give you the points for AB. Remember, CD is the opposite side from AB. In a parallelogram, opposite sides are parallel. Okay, opposite sides are parallel, so they got the same slope. So all I have to do is find the slope of AB, which is also the slope of CD. So I'm going to use my slope formula with those. Difference of the y's on top, so y2 minus y1, negative 2 minus 8, over the difference of the x's, 0 minus 4. Okay, that makes negative 10 over negative 4, which does reduce to positive 5/2. And so both those sides would have a slope of 5/2. Then it says, what is the length of CD? Well, same thing. CD is equal to AB in length. So I'm just going to use my distance formula again. All right? I'm going to use my distance formula. We're going to take the difference of the x's, so 0 minus 4 squared, plus the difference of the y's, negative 2 minus 8 squared. Okay, and we're going to simplify this. 0 minus 4 is negative 4. Negative 4 squared is positive 16. Negative 2 minus 8 is negative 10. Negative 10 squared is positive 100. So I want the square root of 116, and let's go ahead and round that to the nearest 10th place, which gives us about 10.8. So both sides, AB and CD, would have that length, about 10.8. Okay? All right, now we're going to take a look at our next couple examples. Some of these we'll do in the video, some of these we'll wait and do in class. Just make sure you're paying attention and listening, please. Okay? We're going to skip over this example and come down to this one. We're talking about our square here. Okay, we've got a square ABCD, all right? But the order of these letters still tells us which pieces go together. So we're asked to find the length of side AD, if that was a square, and the perimeter of the square. Remember, if I can find the length of one side, it's a square. They're all the same, so I just multiply by 4. Whatever answer I get from A, multiply it by 4 to get the perimeter. And then it wants the area. So we're using our perimeter and area formulas for a square. Well, perimeter of a square is 4 times the side length. And the area of a square is that side length times itself, or side length squared. Okay? And so really all we have to do is find the length once, using our distance formula once. Okay? The side length that we find, S, that we use in both of these, is just your distance formula. It's that big long square root. So the length of AD would have to also be the length of AB, because it's a square, all 4 sides are the same. So I can just use these numbers. So I'm going to do the difference of the x's, -2 minus 0 squared, plus the difference of the y's, 5 minus 3 squared, which gives us -2 squared, which is 4, and +2 squared, which is also 4. So that's the square root of 8, which is about 2.8. Okay, so for my perimeter, I'm going to do 4 times 2.8. We get 11.2. And then for my area, we're going to do 2.8 times itself, squared, which is about 7.84, or 7.8. And so that's how we're going to use some of these formulas to solve problems. In this next set of examples, we're actually going to use characteristics of parallelograms to find missing coordinates, meaning I'm going to give you 3 of the 4 vertices, and we're going to use what we know about our graphs and our characteristics of parallelograms to find these missing points. And so the very first thing I want you to do here underneath this first example where it says quadrilateral ABCD is a parallelogram, what are the coordinates? Underneath that question, I want you to draw your own graph in. Okay? Normally I would give you graph paper, but we can just draw our own graph in here. And we're going to plot points A, B, and C and help use that graphing capability to find the missing point D. So we're going to plot point A at -2, 3. So from 0, go back -2, then up 3. So there's A. B is at 4, 3. So I'm going to go over 1, 2, 3, 4, up to 3. So these should line up, A and B should line up as a horizontal segment. C is at -1, -2. So I'm going to go back 1, but I have to go down 2. There's C. Now, these go in order, A, B, C, D. D cannot be over here. D has to be over here for this to be a parallelogram, because we have to go from A to B, then to C with a side before I go to D. That means D has to be over here somewhere. Well, to know exactly how it is, there's a lot of things I want you to remember, or a lot of options you would have. You don't have to do all of these. One thing we know about parallelograms is that opposite sides are congruent and parallel. So side CD should be the same length as AB, and it should be parallel to AB. Since AB is horizontal, I know that in my coordinates of D, the y values are going to be the same. So A and B have the same y value of 3. C and D will have the same y value of -2. Okay, it's going to be along that horizontal line at -2. That wasn't very straight, but you get the idea. Okay, and we also know that they're going to be the same length apart from each other. Anytime I have horizontal lines, I don't really have to use the distance formula, because B is a x value of 4 and a y value of, and A has an x value of -2. Those are 6 apart. So C and D have to be 6 apart. So I'm going to take and count 6 back to the left from -1, or it's like I'm doing -1 minus 6, which equals -7. And that would have to be the coordinates of D. Okay, and so we are going to stop the video here. We will get to the rest of our examples. Okay. Okay, we'll get to the rest of these examples. They take a little bit more time in class then, and we're going to use these characteristics of quadrilaterals to help classify when I give you all 4 of these points. But that covers most of our examples. Make sure you have listened to this video. I hope you did. I hope you didn't just skip ahead and copy things down. That's not a good way to try and learn mathematics. You got to learn by doing and by listening and observing, not just copying down. So hopefully this made a little bit of sense to you. If you have any questions, please come talk to me about it either in ACLAB or in class.